Hey. All right, we've got another one. All right, you better strap yourselves in because this one, I've got a feeling it's going to be lengthy. So I apologize in advance, but please try to stick with me. Try to stick with me. Okay, so today, oh, okay, fine. Have a joke. When do ducks wake up? They wake up at the quack of dawn. Quack, quack. Ha, 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 ha. All right, now let me share something with you guys. Here we go. So today we're going to talk about the definite integral and its properties. You guys have done integrals before, but now we're going to take a look at a little bit of the specifics of, I guess, how we use it practically. Now remember, a definite integral is just any sort of curve or line that's integrated between 2 points that we kind of give you. Now a definite integral, it can be positive or it can be negative. I'll explain more in a little bit. But we have to, and I'll just touch on this now, I won't go into depth, but when we start talking about area under a curve, if I talk about area, or area is always positive. Okay, so an integral can be negative, can be positive, but if I'm finding the area under a curve, it's always going to be positive. Now, let me show you an example of, I guess, how that works. Let's take a look at this. So we've got this beautiful line, y equals x, as simple as you can get. And I'm just picking between -3 and 3, just for fun. And I've labeled, I guess, the left-hand side red, right-hand side green. But let's just see what happens if we were to actually do these integrations. So if we integrate this and we evaluate it, okay, we raise 1 to the power of x, so that'll be x squared, and we divide by the new power. So it'll be x squared on 2. And we're going to evaluate it between 0 and -3. And so that just becomes 0 squared on 2, take away -3 squared, which is 9 on 2. And that's going to give us an area of, I think it's just going to be -9 on 2 units squared. Yeah. So see how we've got between 0 and 3, which is talking about this part here, right? That's what's actually going on here. We're talking about between 0 and 3, and we've got a negative kind of answer. Now, if we did a very similar thing here, but now we started talking between 0 and 3, I'm just going to stick because it is the same integration. The only difference is where we're defining it. So it's going to be between 3 and 0. Now, what we get now is we get 9 on 2, because that's 3 squared on 2. Take away 0 squared on 2. So that's just going to leave us with 9 on 2. And we can see here that there is positive. Okay, so this little section here between 0 and 3, it's a positive area. Now, what happens if we go all the way from -3 to 3? Okay, now before I even do it, I want you to have a think. What if we took the integration all the way between -3 and 3? We know that between -3 and 0, it's -9 on 2. And we know between 0 and 3, it's +9 on 2. So this one here, it actually makes a lot of sense that it will actually end up being 0. Right, so you can see if we talk about area under a curve, it's not necessarily correct. But if we talked about the definite integral, it would be 0. So let's take a look real quick. It's going to be x squared on 2 between -3 and 3. And so that's just going to give us 9 on 2. Take away 9 or -3 squared on 2. Right, so that's actually going to give us 9 on 2, take away 9 on 2, which is in fact 0. So we can have positive or negative, I guess, or 0. But if we're talking about area under a curve, it's always going to be positive. Now, all of this, maybe before I get into that, I'll leave you a bonus here, and I'm wondering if you can find the integration between 3 and -3 of the absolute value of x dx. Now I'll give you a hint, sketch and draw. Okay. I'll leave that there. Maybe I'll upload it later. I don't really feel like it, but it's fine. Okay, so now there's something that this comes in handy especially when we know something about these functions, especially if we know if they're odd or even, we'll actually start to get a bit of an idea of how our integration can look like or what it happens, and it makes life easy for us. And now just a recap here, I've written down, okay, if you have an odd function, it means it's symmetrical about the origin. What is it? What do you call it? The formal definition, that's the one. If we're talking about between, for an odd function is if you have f of negative x, it becomes negative fx. So you substitute that in. I'm not going to go through that today, but that's just the formal definition. And then here's the important part here. If we have the integration of an odd function between a negative value and a positive value of the same magnitude, so for example, between -2 and 2, or between -10 and 10, and it's an odd function, we know that our integration is going to come down to 0. Now, if you take a look here, that's kind of what happened here, right? We got 0 as our answer. Technically, y equals x is an odd function. There you go. So, and an even function is slightly different. If it's symmetrical about the y-axis, you're going to have this idea of f of negative x is the same as f of x. So same thing. Now, what happens here is if I was to take an integration between two things of the same magnitude, right? So again, between like -2 and 2 or -5 and 5, what happens is you can just almost think of it as just do 1/2. So instead of going all the way from -5 to 5, I'm just going to go from 0 to 5. I'll find out what that area is, and then I'll just double it, which is why you have this formula here. Okay. Now, again, these are just kind of terms that I'm going to throw around for now. Now, why do we care about all these things? Now, if you haven't picked up already, areas bound under the x-axis, they come off as negative. Areas bound over the x-axis, they counted as positive. Okay, it's just the nature of these integrations. So that means if I take a look at this, here is an area bound on top. That area there would be positive. Okay. Now, again, this here is also on top of the x-axis. So that there is also going to be a positive area. And this part here, you can see is under the x-axis. So take a guess. Did you guess it? Hopefully you did. This is a negative area. Okay. Negative area, positive areas. Okay. Now, I'm going to go through a whole bunch of other notes that you can do with integrals. They will become handy as you get into more and more difficult integrations. But for now, it's going to be a little bit dry. So hang tight with me. Do you hear that plane? Man, yeah, I can't wait to go traveling. Okay, so rule number 1, and I'm just going to see if I can remember this because I wrote these notes a while ago. Rule number 1 with integrals, you can break up an integral. Okay, so in other words, if I took a look here, and normally what I would do is, I'll write this underneath here. If I wanted to find the whole thing, that could be the integration between 0 and b. So between the whole thing of fx dx. But what I can do is if I wanted to, I could break it up into 2 separate integrals. So I could break it up between 0 and a of fx because my function doesn't change. And then add whatever so I've done 0 to a, and now I want to do a to b, right? A to b of fx dx. Sorry, I should have gone the other way around, b, a, right? Bigger numbers always on top. Right, so that there is an example of how you can break up an integral. It may come in handy if you've got a difficult integral or you just want to find bits and pieces, you can break it up, okay? Second rule, okay, an integral of 0 width is always going to be 0. So if I wanted to find the integration between a and a of, again, this function fx dx, if you took that line, is there any area under this one-dimensional, one-dimensional kind of line? No, not really. So in that case there's going to be no area under the curve between those 2 spots. Area would be 0. Okay, so that's what that one is. Yeah. All right. Now, here's one that I've seen a little bit in the HSC. Now, if you reverse the interval, it changes the sign. Now, when I talk about sign, I'm talking about positive or negative. All right, that's what I mean by sign. Okay, so reversing the interval changes the sign. So if I went like this, right, if I, whoops, maybe, yeah, sure, let's write it like this. All right, if I change the interval, if I reverse the interval, instead of from B to A, I went from A to B. So I went the other way around for some reason. It'll just be the negative version of whatever it was previously. Okay, so reversing the interval changes the sign. Hopefully you remember that. Hopefully that is something that that comes up in your HSC this year. All right, moving on. Number 4, I know there's a lot of rules. Stay with me here. Integrating a sum of functions is equal to the sum of the integrated functions. All right, this is one of those tongue twisters. All it really means is I can just integrate both and add them separately. So if I've got the integration of 2 functions added together, I can just do one at a time. So in other words, it's going to be my b and a of fx dx. And I'm just also going to add the integration of b to a gx dx. Yeah, hopefully that makes sense. All right, and again, if I have 2 separate functions, I can combine them into the one. All right, now this is probably going to be your most used one. I see this one as the most common. If you have a multiple of a function, it can be taken outside the integration. So simply put, that k there is our scalar. So it means it's kind of like just a multiplier of a certain function. If I can have a multiplier out the front, I can take it out the front like this, and then I don't have to think about it in my integration. Okay, so I've taken it out the front. All right, now this one here, I've written down logic works in integration. And I've written it down because it's a little bit messy. I don't necessarily think you need to memorize this. It's not something that you're going to be tested on, but it just makes sense. Right, now we see here that fx, right, this red function is a lot less, or it's a lot closer to the x-axis or to the 0 than this blue function, right, gx. So if it just means that if fx is less than gx, if we integrated and found the area under each curve, the area under the red curve is going to be significantly less than the area underneath the blue curve. Makes sense, right? So that means if fx is less than gx in some sort of interval a and b, right, and I've just written a and b there, we know that the integration of fx dx between a and b is going to be less than the integration of gx between a and b. Right, so it's just logic kind of holds, it works in integration. Now, these are the rules that you're going to use in, I guess, as you integrate more and more tricky integrations. But for the moment, that's it. Hopefully that was not too much. Hopefully that was okay. If you have any questions, again, please leave a comment or ask or email. Please don't just sit there and be like, I don't know what happened. But again, hopefully when we cover this in class, you guys will be like, yep, got it, sweet, makes sense. All right, cool. Anyways, peace out, you guys. Take care. Happy mathing, and I'll see you later. Bye-bye.